5-step approach to hypothesis testing. 1. Formulate the hypotheses. Start by stating both the null hypothesis, HO, which assumes no effect or difference, and the alternative hypothesis, H1, which assumes there is an effect or difference. 2. Choose the level of significance. Set the level of significance, often represented as alpha symbol, typically 0.05 or 0.01. This value represents the maximum probability of making a type 1 error, rejecting the null hypothesis when it's actually true. 3. Select the test statistic and determine the decision rule. Choose an appropriate test statistic based on the data type, sample size, and distribution, such as t-test, z-test, or f-test. Establish the decision rule, which will guide whether to reject or fail to reject HO based on the test results. 4. Compute the test statistic. Using the sample data, calculate the test statistic, e.g., t-value or z-value. Then compare this value against the critical value or use the p-value approach to assess whether the result falls in the rejection region. 5. Draw a conclusion. Based on the calculated test statistic and decision rule, either reject or fail to reject the null hypothesis. This leads to a conclusion about whether the observed effect or difference is statistically significant. Testing for normality. A normality test assesses whether data follows a normal distribution, an essential assumption for many statistical tests. 1. Shapiro-Wilk test, ideal for smaller samples, less than 50, although it can be used for larger samples. 2. Kolmogorov-Smirnov test, suitable for larger samples, n greater than or equal to 50. Both tests start with the null hypothesis that the data is normally distributed. If the test result is significant, p-alpha, the data does not follow a normal distribution. Skewness and kurtosis. Skewness measures the symmetry of a distribution. If skewness is close to 0, the data is symmetric. Positive skewness indicates a tail on the right, while negative skewness suggests a tail on the left. Kurtosis measures the peakness of the data distribution. Excess kurtosis, kurtosis -3, helps in comparing distributions with a normal curve. If kurtosis, excess, lies between -1 and +1, the data distribution is approximately normal. A symmetric distribution shows balance around its central point. When the mean, median, and mode are approximately the same, skewness and excess kurtosis are around 0, indicating a close to normal shape. Testing significance of differences between means. Several statistical tests help evaluate differences between means. 1. Z-test. Used if the population standard deviation, sigma, is known and sample size, n, is 30 or more. 2. T-test. Applicable when sigma is unknown and sample size is 30 or less. 3. F-test. Used when comparing the means of 3 or more groups. Types of hypotheses tested with a z-test. 1. Comparing population or hypothesized mean. Tests if a sample mean differs significantly from a population mean. 2. Comparing two sample means with known standard deviations. Tests if the means of two independent samples significantly differ. 3. Comparing two sample means with known population standard deviation. Assesses if the means of two groups differ significantly when the population standard deviation is known. These tests are crucial in research, providing a structured way to analyze data, verify hypotheses, and ensure meaningful conclusions based on statistical evidence. Hypothesis testing helps school leaders make data-informed decisions on various aspects such as evaluating the effectiveness of teaching methods, testing the impact of new policies or curricula, measuring student or teacher performance changes over time, understanding factors influencing student outcomes, such as attendance, socioeconomic status, or learning environment, comparing different programs or interventions to determine which is more effective. Advantages. Structured analysis. The 5-step approach provides a clear, methodical way to examine hypotheses, improving the reliability of results. Informed decision-making. Hypothesis testing helps leaders make decisions based on data, reducing bias and improving educational outcomes. Testing of educational interventions. allows schools to test specific initiatives or programs, promoting evidence-based practice. Disadvantages. Risk of errors. There's always a risk of making type 1, false positive, or type 2, false negative, errors, which may lead to incorrect conclusions. Complexity. This process can be complex, especially when assumptions, like normality or equal variances, are not met, requiring more advanced statistical knowledge. Data limitations. In education, it's sometimes challenging to get representative data due to factors like limited sample sizes, missing data, or uneven participation. Application in educational management. In the Master in Educational Management (MEM) program, hypothesis testing is crucial in research and decision-making. For example, a school leader may use this process to determine if a new reading program significantly improves students' reading scores compared to a traditional method. By formulating a hypothesis, setting an alpha level, running the appropriate test, and analyzing results, the school leader can make an evidence-based decision on adopting or modifying the program. Additionally, MEM students may use hypothesis testing in their research to evaluate factors like teacher training impacts on student performance or the effectiveness of different educational technologies. By applying the 5-step approach, educational management professionals can draw reliable conclusions and create strategies that are grounded in research.